Imagine that you have a flat sheet of cardboard and you're going to make some cuts in it along these dotted red lines. And once those cuts are made, you're going to fold this thing so that those wings on the sides and the top and bottom fold up, and it makes a three-dimensional figure. We're going to figure out what the optimum volume for this is based on some dimensions of x and y, x and w. So first, we're going to walk through this and say, what's the equation for the perimeter? Now that's very easy, right? We just say x plus x over here, w plus w over here, because those sides are the same. It's a rectangle. So we get a perimeter equation that looks like the following: 86 inches, and you can see that hopefully right here if you've read the paragraph. 86 inches equals 2x plus 2w. Okay, moving on. Second part. What's an equation for the volume in terms of the side lengths x and w? So now this is going to get a little more complicated, and I'm going to bring this over here on the right side. I'm going to say my volume equals, and I have to think about the footprint. That's where this gets tough. So the footprint, what I'm calling the footprint, is this area right here, okay, that I'm shading in. That's going to be the bottom of this box that we make once we fold up those wings. And what's the dimension of that going to be? Well, you see what x is right here? The trick is you have to know what you're subtracting off of x. Now, I've labeled 5 all over the place where these cuts are written. We've been told that we're cutting 5 inches into each corner. So if we imagine if that's 5, then what's this portion right here going to be? Well, it's simply x minus 5 minus 5, right? Because of those two cutouts. So my first dimension of that green section is going to be x minus 10. And then in the other direction, over here, that's going to be w minus 5 minus 5. Same idea with the cutouts. So that's going to be w minus 10. And the final dimension, this is the part that's hard to visualize, but it's coming directly up vertically off the floor. That's going to be 5 inches. Okay. Now, you can put that directly in here because it's not asking you to simplify or anything like that. We're just going to run with that equation. Or you can simplify it if you like. That's fine. But now, in the next step, I want to use only the variable x. Okay, and this is getting towards how we're going to solve this problem eventually. I want to get rid of the w and only have x in here. So what we have to do for that is we have to combine our previous equation. Now see this equation? I'm going to rewrite this by dividing both sides by 2. Watch what's going to happen. I get 43 equals x plus w. And then I can rewrite that to say w equals 43 minus x. Okay, so that's handy. Now I'm going to take that and I'm going to plug it into this equation right here where the w is. Okay, so watch what happens when I rewrite this. It's now going to be equal to x minus 10 times 43 minus x minus 10. And then you have that 5 left over at the end. Okay, so that's my new equation for volume. But there's one more trick. You can't just put that in. It says write it in standard form. Okay, no problem. That just means simplify it a little bit. So we get x minus 10, first parentheses. Second parentheses simplifies to 33 minus x. And then we have times 5. I'm going to skip what comes next, or at least I'm going to move through it kind of fast. This becomes, let's see, 33x minus 330 minus x squared plus 10x all times 5. If you want to see the quick version of what I did, I was basically doing distribution, right? I was multiplying each of these things in the first parentheses by each of the things in the second parentheses. And what that's going to be equal once all the dust settles is the following. Negative 5x squared plus 215x minus 1650. That's a big boy. So there's my volume equation, and that goes right in here. Okay, so that's negative 5x squared plus 215x minus 1650. All right, so moving on, it wants to know a domain that actually makes sense in the context of this problem. So what that means is you have to look at the x values and think, what would totally break this thing? Well, if x was less than 10, think about what would happen. If this value right here is less than 10, that means when you make those 5-inch cutouts, there's nothing left. So 10 is the lowest I could possibly go. And if you think about what's the biggest x could possibly go, well, that's when w is basically the minimum. So if w is the minimum, that means w is 10. And using this equation right here, with w equals 10, now we know that x can be as big as 33. So that's the highest we could go in the other direction, giving us a domain of 10, 33. Okay, last bit. Now, when it says the word optimum or optimal value, you have to remember this is like a vertex. We have a quadratic equation right here for our volume, and I want to find the vertex. So the way we do that is we say h equals negative b over 2a, our good old formula, and we just plug in b and a. So this is going to be negative 215 over 2 times a is negative 5. So we get 21.5 in this case. That's the optimum x value to give me my optimum volume. And how do we figure out volume? Well, we just plug that in to our equation for volume. Now we have, let's see, 21.5 squared plus 215 times 21.5 minus 1650. Where's that equation coming from, you might be asking? Well, it's this one up here, right? This thing that I have for my volume. I'm just plugging in my optimal x into that, and that will give me the total volume of this thing, which turns out to be 661.25. So check your numbers against mine, see if you're doing it right.